Hello, everyone. So, from today, I'm going to start a new playlist on monotonic stack. Um, Actually, most of you might know what is this monotonic stack, and I do feel that it is actually very important topic asked in many good top MNC companies when they ask for the interview, when they ask for the coding questions. This is actually very important topic. Once you understand some of the algorithms under monotonic stack, then you'll be able to realize that in which type of questions you can use this monotonic stack. It could be used in many questions. Once you get that insight that here I can use monotonic stack, that question then actually becomes very, very, very easy. So, without just wasting time, I just wanted to brush up your knowledge about stack. So, stack, as you all know, is a LIFO kind of data structure, which is last in, first out, right? So whatever you enter at the last, when you'll pop out the things, that thing will come out the first. Okay. So if I tell you, uh, like this, if we draw, and I have an array which is like 1, 3, 2, 7, 5, 9. Okay, so I'll be entering 1, 3, 2. And when I have to pop, so I'm pushing it in this manner. But when I'm popping out, I'll be removing it from 9, 5, 7. So when I'll remove, I'll get it in the form of 9, 5, 7, 2, 3, 1, which is reversed order. Why? Because last I have entered is the ninth element, and then I have entered before to 9 I have entered 5 and 7 and so on. So when I'll remove it in the opposite direction. So whatever is entered first, that will be taken out at the last. Last in, first out is the basic principle of the stack. Okay, stack you can mainly use in the kind of questions where you feel like until this point you have to push, and then you need to pop out the things. So there are four different operations on stack. Push the num, with this will push the element num into your stack. To define your stack, you have to define its stack, whatever is the data type you want to define, and the name of the stack you want to give. Then the pop will not do anything. Okay, it will just remove the top element from the stack. If stack is not empty, then only you have to do the pop operation. If stack is already empty and if you do the pop operation, you will get the runtime error. Okay, then we have top element. Top element will return the top value from stack, right? So as of now, if I have not popped anything and if I write st.top, it will give me what? It will give me 9. Okay, if I pop this one time, if I run the pop operation, 9 will be popped out. Next time, if I run st.top, 5 will come out. I hope you got. And then we have st.empty to check. So this will return true or false if stack is empty or not, depending on the stack is empty or not. So if stack is empty or not. Depending on that, it will return true or false. Okay. And then we have stack dot size. This will return total number of elements in the stack. Total number of elements in stack. Okay. So these are the basic operations of the stack. Okay. These are the basic operations of the stack. Now comes a monotonic stack. Okay. So now we have monotonic stack in the picture. What does this monotonic stack means? So we'll feel the stack in such a way that it is either strictly increasing or strictly decreasing. Now what do I mean by this? There could be two type of monotonic stacks: increasing monotonic stack, increasing stack, or decreasing stack. So I'll feel the stack in such a way that it remains either strictly increasing or strictly decreasing. This is the normal stack. I have filled it in this way only, in the array wise, while traversing the array 1, 3, 2, 7, 5, 9. So this is not increasing. Until 1, 3, it is increasing. Again 2 came, so it is decreasing. Again 7 came, increasing. Again 5, decreasing. Again 9, increasing. So this will store in the zigzag pattern, not a fixed pattern. Okay. But now for the monotonic stacks, normal stack only. Nothing to change in the functions, nothing to change with the operations to methods we apply on the stack. The only change is we will store this we will store the values in the stack, or we will fill the stack in such a way that it becomes either strictly increasing or strictly decreasing. Okay. Let's say you have been given this array only. So whatever I have written above, you have been given this array only: 1, 3, 2, 7, 5, 9. And you have to form the increasing stack. Okay. So you will store 1, then 3 is increasing than 1. I mean greater than 1. So you will store it. Okay. Then again 2 is not greater than 3. So you will not store this. Or you will store it in another stack, I could say. Then 7. 7 is greater than 3. So you will store it here also, here also. Because 7 is greater than 2 also. Then comes 5. So 5 is again not greater than 7, not greater than here 7 also. Let me push it somewhere else. And then I have 9. So I'll store 9 everywhere because 9 is greater than all of the 7, 7 and 5. So I could have three different increasing patterns here. 1, 3, 7, 9 is one, 2, 7 and 9 is another, and 5 and 9 is another. I could say I have got three different patterns which is strictly increasing of out of this array, which is Q1. Okay. So basically the problem here lies around four different algorithms. Okay. Now this could be strictly decreasing also. If you want, I can show. So let's say 1. Now 3 is not decreasing than 1. So we will not store 3. We'll store 3 in another stack. Okay. Now 2 is lesser than 3, but not lesser than 1. So we'll not store 2 over here. We'll store 2 over here only. And then we have 7. So I'll of course store it in somewhere else because 7 is not less than 1, not less than 2. 5 less than 7. I can store it here. Can I store here where? No. 9 somewhere else. So I have four different strictly decreasing patterns. 1, nothing less than 1 is present in the full array, right? Then 3 and 2, anything less than 2 present after 2? No. Then 7, 5, anything less than 5 present? No. And 9. So four different strictly decreasing patterns I have found in this array. Okay. Now your question lies mostly around the four different patterns: next greater element, next smaller element, previous greater element, and previous smaller element. Okay, so what do I mean by this? Next greater element is at whatever position I am, let's say 1, I need to find the element which is next greater than just 1. So which is at 3. Almost of course this 3, 7 and 9 all are greater than 1, but I just want the next one. I just want the next one, which is 3. Okay. After 2, so after 2, yes, I have so many things after 2. I mean 7, 9, everything. But I just want something suddenly after 2, which is 7. Okay. Suddenly after 7. So suddenly after 7, I have something which is greater is 9 only, not 5. So the next greater element of this 7 is 9. Similarly, next smaller element could also be found. Previous greater elements could also be found. Something just greater than on the left hand side, previous side. Okay. And previous smaller element could also be found. And with the combination of this four, there are so many questions which can be solved. This we will do when we go later in this playlist on how different types of questions could arise which you can solve using this monotonic stack. Okay, so today we'll cover next greater element. I'll take another video for next smaller, previous smaller, and previous greater. All these three combined in that particular video. And then we'll go on to the different type of questions. So today I'm going to cover next greater element, right? Which we call as NGE also sometimes. Let me take that particular example itself: 1, 3, 2, 7, 5, and 9. Okay, cool. Now you have to store the next greater elements. Now, next greater elements of every index, right? So this will return us what? The answer array of size n, okay? The answer array of size n, where answer of I is next greater element of ith index. So next greater element of 1, next greater element of 3 is stored here, 2 is stored here, and so on. I hope you got my point. Okay. Now there could be two things you can do depending on the question. Okay. Depending on the question, you can either store index of next greater element, or value itself in answer. I mean, I can store what is next greater than 3 or next greater than 1. So 3. Then 3, 7. Then 2, 7, 7, 9, 5, 9, 9, nothing. So minus 1. Minus 1 if no element is greater on the next side, I mean on the right side of the current element. This could be one of the way. That could be another way of storing indexes. Okay. So after 1, so these are the indexes 0, 1, 2, 3, 4, 5. Okay. So 0, this is 0th element. Which index's element is greater than the 0th index element? So first index element. So I'll store first over here. This one is not value, this one is index. So at 0th index of answer, I've stored 1, means the value at 1th index of the array is greater than the value at the 0th index of the array. That's what I mean to say. Okay. Similarly, for 3 is next greater element. So the next greater element lies at third index, 7 which is. So I'll store 3 over here. For 2, again third index. For 7, fifth index. For 5, also fifth index. And for 9, nothing. So again, minus 1. I hope you got. So depending on the question asked. So question could be asked sometimes related to length of something. So when asked for length, of course, you need to have indices so that you can subtract 5 minus 3, 2, something kind of this to get the length. Okay. But if value is asked, you can directly store the values. Otherwise, you can store the indexes. I hope I'm clear. Now the question arises as to how to find the next greater element. Okay. So now we have come to how to find next greater element. Again, let's go through this example 1, 3, 2, 7, 5, and 9. I will traverse the array. First step, make answer array of size n, of course. Okay. Second point, traverse the array in reverse direction. So I'm traversing it from backwards. Okay. I'll help you remember these templates when we will cover in the next video previous greater, previous smaller, and next smaller. These are actually very easy techniques to remember these templates. So I need to I will traverse in this direction. Okay, so first I came up with 9. While stack is not empty, and stack dot top element is less than equal to current element, pop it. What do I mean to say? I'll cover it while we do the traverse. Okay. Otherwise, fourth point is now if stack is not empty, stack dot top is the answer or next greater element for ith value. Okay. And fifth, push current element in stack. Okay. Let's see how it works. Again, I have 1, 3, 2, 5, 7, and 9. Sorry. 7, 5, and 9, right? 1, 3, 2, 7, 5, and 9. Now I have started traversing in the opposite direction. Okay. So initially I have initialized one stack. Okay. Initially nothing is there in the stack. I have made one answer array and initialized it with the -1. So all the values are -1. So that if at all no next greater element is present, it's by default is -1. Okay. Now we have come up with the 9. So for the 9, there is no element in the stack, of course. So my third point says if stack is not empty. Okay. But already stack is empty. So we do not have to focus on third point. On fourth point also the same thing if stack is not empty. Okay. Fifth point says just push it. So I've pushed it in my stack. Okay. I have come to I is equal to 5, 4. Okay, where the value is 5. Currently, I'm storing the values in the stack and the values in the answer. You can store the index also in the stacks and index in the answers. Now I have come to 5. So for the 5, until my stack is not empty and the elements in the stack are lesser than equal to 5. Is there any elements less than equal to 5? No. Now, you might have understood why am I trying to say less than equal to 5, so that I can pop those elements until it is less than equal to 5. Okay. So as of now, there are no elements less than equal to 5, so I'll not pop anything. What I'll do, the fourth point says if the stack is not empty, the top element of the stack is your answer, is the next greater element. Correct. So here it stays -1 only. Here it comes as 9. Now, the top element. You will not pop this out. You will not pop this out. And you will push 5. Now comes 7. Now comes 7. For the 7, the third point says if or while the stack is not empty and the top element is less than equal to 5, less than equal to 7, current element. Yes, 5 is less than equal to 7. What do I want? I want next greater elements. Okay, I want the next greater elements, not smaller elements. So I'll remove this 5. I can remove this 5. Do 5. Uh, if I remove this 5, can 5 be the answer of something in the previous points, previous indexes, which I have not yet traversed? Can 5 be the possible answer of something previous? Of course not, because I have got something 7, which is of course greater than 5. So if at all I have to find the next greater element, 7 could be my answer, but at least not 5. I hope you got. Because I've got 7, which is greater than, of course, 5, and it is ahead of 7. It is ahead of 5. The question says I need to find the next greater element. Okay, so I can remove this 5. Now I don't need this 5. And I will push 7. Okay, I have to remove all elements less than equal to 7, but only one is there over here. So I'll remove this 5. Now I have only 7. Okay, before pushing 7, I'll see the top element if it is not empty. Yes, 9. So 9 is my answer for this index also, and then I'll push 7. Okay, now for 2, I'll need to pop all the elements less than equal to 2 if present in the stack, but nothing is there. The top element is only 7, so everything beyond is of course greater than 7. So you could see that my stack is becoming decreasing stack. Okay, monotonically decreasing stack it will become. So if nothing is there, what will I do? The top element is the greater element of the current next greater element, and I'll push 2. Now when 3 comes, okay, when 3 comes, 3 will say that okay, I don't need 2, I want next greater element, and this 2 could also not be the answer of anyone ahead of 3. 3 will say no, then I will become the answer of someone ahead of me. At least I'm greater than 2, right? So I can remove 2 from here. So 3 will remove this 2. 7 is greater than 3, so 3 will not remove the 7. The top is 7, so 3 will say that okay, 7 is my next greater element, and then 3 will be pushed. Now for the 1, 3 is of course greater than 1, so it will not pop this 3. What it will do? It will take this 3 as the answer and it will store on top of this 3. So it will store here. So you could see our stack has become 9, 7, 3, and 1 finally. So this is monotonically decreasing stack has become. Right. This is decreasing stack it has become. It was stored in this manner, not in this manner. But if you will remove from this stack, you will get 1, 3, 7, 9, which is increasing pattern you will get. Okay, and you've got your answer array like 37799 minus 1. Fine. Okay, let's just do a coding of it. And I hope you have got this very clearly how to find the next greater element. Okay, so we could have vector of int next greater element of n comma minus 1. Okay, now what I could do is I already have array of size n. So n minus 1 till 0 will traverse in opposite direction while stack is not empty and stack dot top element is less than or equal to your current element. Your current element will be array of I. What you will do is you will just pop it out. Again, if not stack dot empty, then only your answer is the top element. If stack is empty, then top you will not get. You will get runtime error if it is empty, right? So if it is not empty, your answer of I, which is nothing but next greater element of I, is stack dot top, and you will push the current element in the stack. Simple and easy. Next greater element will return next greater element. This is your final array. So I'll be giving you some questions of next greater element, one or two questions that you can solve. And in the next video, I'll be going to cover previous greater, previous smaller, and next smaller. And the way to remember all these templates, how you can remember all these templates. So stay tuned for the next video. Do like, share, and subscribe with your friends if you have learned a lot out of this. Bye bye.